Introduction to Unit Testing in Microsoft Visual Studio 2012. Contents. Introduction. Importance of unit testing. Define a paradigm. Things to consider. Using a testing framework other than Microsoft Test. Installing xunit.net. Installing nunit.net. How to write testable code. Hard to test code. How to write testable code. Refactoring to interfaces. Introduction to unit testing. There are two schools of thoughts when it comes to unit testing. Those who argue that you never should change the design of existing code to make it more testable, and those who say you can. What school you belong to determines how you will utilize isolation frameworks such as fakes in your testing. If you belong to the latter category that thinks it's a good thing to change the design to make it more testable, then shims in the fakes frameworks will be a possible route for you. Shims are a way to substitute concrete classes and are used to test legacy code that was not designed to be testable. This documentation does not put any judgment either way. The choice is yours to make. The main thing is that unit tests should be small and fast to execute. What is software testing? Software testing is a way for the team to achieve the definition of done. Definition of done is a way to measure and maintain the quality of your software and code in a way that ensures user expectations, business requirements and value, security, recoverability, and reliability. When the team discusses and comes up with a definition of done, it can be helpful to consider design, code reviews, refactoring, and testing. Traditionally, testing is divided into three strategies: white, black, and gray. White box tests are used to analyze the inside of the box when it's possible. This means that you have access to and knowledge of the code of the external DLL. Or you have the possibility to reverse engineer it to gain an understanding of it using an idle decompile tool. In black box tests, the inner workings of the code are by definition not visible. You typically only have access to interfaces to test the code. These tests focus mainly on input and output. Gray box tests are a combination of the two previously mentioned test types and are generally used when testing edge cases. Important. Because unit tests focused on very small pieces of code, it should not be seen as the almighty tool to solve all testing issues. You should look upon it as one of the cogs that makes the machine run smooth and lets you arrive at the expected end result. As such, it should be used in conjunction with other testing strategies such as integration tests, regression tests, system tests, and user acceptance tests. If you're wondering if unit testing really is that important, then let me put it into another context for you. What if you were an astronaut, embarking on a journey to uncharted areas of the universe? Wouldn't you like the shuttle and protective suits to be tested before you even got aboard the shuttle? It would not be enough that someone told you that it's made of the most durable material on Earth and could withstand the forces of takeoff. No, you would expect that even the smallest detail of the shuttle and suits be tested and retested. Well, that's where unit tests come into the picture. Unit testing is a way to test the smallest possible unit in isolation from other things. Unit testing is an iterative process that should continue throughout the whole project lifecycle. You should use unit testing if you strive for high code quality, fewer bugs, and reduced cost of fixing them. Consider using automated testing to test code challenges quickly on an ongoing basis. You should be aware that automated testing brings its own challenges to the table. Note: unit testing is testing the smallest thing you can test in isolation from other things. Depending on your code, that might not be that small. Good design makes it easier to unit test the application. Some believe that testing legacy code or code that you don't have direct access to is impossible. That is not the case, however. We can always use fakes. Define a paradigm for unit test development. One strategy that is widely used for test-driven development and that is especially used for agile development is the red fail to green success strategy. There are 4 main steps to this strategy: stub, code, refactor, and maintain. Stub. In this step you stub out the code in the test function first, from red to green. Initially the code will fail, red, due to lack of implemented code. You then implement just enough code to get the code to pass the test, green. No real code implementation has been done so far, only interfaces and empty functions have been implemented. If you prefer, you can have the items auto-created as you write the test code, by right-clicking on the code and selecting Generate from the context menu. Code. Implement the code. First the test will fail, red, due to missing functionality. Implement the requirement defined by the test code until the test succeeds, green. Refactor. When the test and code are green, you might want to refactor the code as the solution evolves. Maintain. When the unit test is finished, it's important to maintain it as a first-class citizen and adhere to coding practices, version control, and build test automation. Things to consider. Using a descriptive naming convention is important to be able to distinguish different tests from each other. For a small project this might not seem like a big deal, but consider that even a small project can have hundreds or even thousands of tests. Apart from a naming convention, you could also separate tests into different classes, maybe using the same folder structure and class names that are implemented in the project being tested. An example of a naming convention for test functions is class name _purpose _expected result. For instance, class name could be order, purpose could be number of order rows greater than 0, and expected result could be succeed. That gives us order number of order rows greater than 0 succeed. Or class name could be order, purpose could be number of order rows equal to 0, and expected result could be fail. That gives us order number of order rows equal to 0 fail. When it comes to documenting the code, less is better than more. The code should be as descriptive as possible to minimize the use of comments. Asserts and error messages should be clear and descriptive to improve readability in the build log. Example: saving of order failed due to lack of order rows. Each test should only test one thing, one logical assert. The logical assert can, however, consist of multiple assert statements. Use interfaces when implementing. This helps greatly when doing black box testing and when using stubs. Avoid testing across application and service layers. Remember that unit testing is designed to test the smallest possible unit in isolation. This can be a class, a method, etc. The test code should hold the same high standard as the rest of the solution, adhering to the same coding principles and company requirements. Using a testing framework other than Microsoft Test. When creating and running unit tests in Visual Studio 2012, you are not limited to using Microsoft Test. You can choose between many different testing frameworks and plug in the framework of your choice and enhance your testing experience. There is now true 64-bit support in the testing environment and the speed has been greatly improved. It is now possible to test async code for long-running tasks. The limitations regarding testing are that you can only use frameworks other than Microsoft Test and the Test Explorer in Professional and Higher. The Fakes framework and the possibility to run tests automatically after build is available in Ultimate only. The old architecture using Microsoft Test has been ripped out and rebuilt to accommodate other testing frameworks that are available on the market. It is even possible to use several of these frameworks in the same project or in the same class even if desired. Note that there are 2 testing frameworks out of the box: MS Test Managed for .NET and MS Test Native for C++. Since JavaScript has been elevated to a level 1 language in .NET, it is now possible to unit test JavaScript projects using Chutzpah testing framework that interacts with QUnit and Jasmine. You can install NUnit and XUnit.NET using NuGet packages. How to write testable code. Unit testing is testing the smallest thing you can test in isolation from other things. Depending on your code, that might not be that small. Good design makes it easier to unit test the application. Hard to test code. Some believe that testing legacy code or code that you don't have direct access to is impossible. That is, however, not the case. We can find code that is hard to test in several places and situations. Business logic. Business logic that is written directly in the code behind files is very hard to test. Class dependencies. Classes with too many dependencies. That is, newing up objects inside the class. Database logic. Mixing database logic with business logic, that is using SQL statements directly in the business layer functions instead of using a separate data layer. When unit testing, we do not want to test the database functionality with the business logic. The two should be tested separately. Testing databases is generally regarded as integration testing. Testability. Code where testability wasn't a consideration from the beginning can be hard to test, and refactoring can be necessary to accommodate unit testing. Monolithic highly coupled design. This should be avoided in most circumstances, especially if unit testing is being used. A monolithic highly coupled design is a single-tier self-contained application where UI and data access is combined into one unit. Indicators of hard to test code. There are certain indicators that you can be on the lookout for regarding hard to test code. Test setup. Complex test setup, where you have to write excessive amount of code before you can do an actual assert in the test function. Environmental dependencies. Code that uses a read, write or change access to a server is very hard to test, because you might not have the same access right on the test or production servers. Static methods. Testing public static methods is hard. Hidden object creation. Object instances that are created inside the functions or lambda delegate functions are very hard to test because you need to know about them in advance when writing the test function, and create instances for them using fakes to circumvent them. External frameworks. Complex external frameworks, such as the framework for SharePoint, can force you to write complex test functions. In certain cases, you are testing in the blind because you have no idea what is happening inside the class constructors. Slow running tests. Slow running tests can be an indicator that the code needs refactoring. Tests that break. Tests that break when you make changes to the code is in many cases a very good indicator that the code needs refactoring. How to write testable code. Isolation is critical. To write testable code, there are certain things we need to use when designing an application or component. Those are abstraction layers, interfaces, dependency injection, stubs, and overrides. Note: stubs are concrete implementations of interfaces that are used in testing or other scenarios where we want to provide our own implementation. They are very fast because they are pre-compiled and use language constructs that are built in. 5 principles of good testable software design. Use the acronym SOLID. S. Single responsibility. There should never be more than one reason for a class to change. O. Open-close principle. You should be able to extend a class without changing it. L. Liskov substitutability principle. You should be able to substitute a subclass for its base class. I. Interface segregation principle. Many small interfaces are better than one gigantic interface. You can then choose what parts to implement instead of having to implement everything. D. Dependency inversion principle. Always depend on abstractions, not on concrete things. Refactoring to interfaces. A good way to implement testable design or refactor existing code to be more testable is to use interfaces. You want to use interfaces because interfaces only expose what you can consume. You never have to wonder about a class's dependencies or what it implements. A class expresses its requirements through interface dependencies. Wrapping external APIs in interfaces provides injection points, making it easier to test because you can substitute the implementation with your own test implementation if the need arises. Useful refactoring patterns. Null object. An implementation that does nothing instead of returning null, which will have to be checked in the code using the object. Default implementation is similar to null object. It's a default implementation used if no implementation is provided. Dependency injection. In version of control frameworks, the class expresses its requirements and the container fulfills.